Welcome all. Let me start today's class. At the end, I will take attendance. Then I will ask everyone to unmute themselves and speak their roll numbers and names so that I can give attendance. Wait. Now all of you tell me if my screen is visible.
Yes, ma'am.
Run the slides. Today we will learn about disk scheduling algorithm. Disk scheduling, as the name suggests, disk is a part of memory management techniques. So disk scheduling algorithm falls under memory management techniques. The operating system is responsible for using hardware efficiently for the disk drive. This means having a fast access time and disk bandwidth. Access time has two major components. Can anyone tell me the definition of access time? What is access time? Anybody, please answer. Correct or not, but anyone please answer me. Anyone who want to answer, unmute yourself and speak. Not getting any answer. Access time is the time which is required to read the data from the point where it is stored. So access time has two major components. Seek time. What is seek time? Seek time is the time for the disks to move the heads to the cylinder containing the desired sector. I have in my earlier process, I have taught all of you tracks and sectors. So if we need to minimize seek time, we have to seek distance first. Disk bandwidth is the total number of bytes transferred divided by the total time between the first request for service and the completion of last transfer. Up to this, do you want to ask anything? Any questions from anyone? Any question? Anybody? Again, I am explaining disk scheduling. It is done by operating system to schedule I/O request arriving for the disk. Wait, I want to share my whiteboard and write something. Disk scheduling is also known as I/O scheduling. Okay, disk scheduling, it is also referred to as IO scheduling. And disk scheduling, why disk scheduling is important? It is important because multiple IO requests may arrive by different processes, and only one IO request can be served at a time by the disk controller. Thus, other IO requests need to wait for the waiting queue and need to be conducted. Two or more requests may be far from each other, so can result in greater disk arm movement. If I am explaining, if there is any confusion, I am asking everyone to repeat. Hard disk are some of the slowest part of computer systems and thus need to be accessed in an efficient manner. So there are, for managing disk scheduling, there are many disk scheduling algorithms, but before discussing them, let's have a quick look at some of the important terms. No problem up to this? Now, wait, let me write something. Some important points. Wait, very sorry. Some important terms are, first is seek time. Does anyone have any idea about seek time? What is meant by seek time? Seek time is the time taken to locate the disk arm to a specified track while the data is to be read or write. So the disk scheduling algorithm that gives minimum average seek time is better. And next term is, first was seek time. First was seek time. What was the next important term? Next important term is rotational latency. The next term is rotational latency. What is rotational latency? Any idea about the definition? Have you ever heard the term? Anyone of you ever heard about rotational latency? What is that? Rotational latency is the time taken by the desired sector of disk to rotate into a position. What is that? Rotational latency is the time taken by desired sector of disk to rotate position. So the disk scheduling algorithm gives minimum rotational latency, that is better. And then the next term, what is the next term? Next term
मैम
is
रोटेशनल लेटेंसी आप जो बोल रहे हैं इसका मतलब ये अपने जगह पे आ रहा है जिस पॉइंट पे हम
rotational.
लोग उसको सीख करेंगे.
Rotational latency is the time taken by the desired sector of a disk to rotate into a position. Okay? So that it can access the read write head. इस तरह से move होगा so that we can access read write head. And so the disk scheduling algorithm gives minimum rotational latency. The scheduling should be done in such a manner that there should be less rotational latency. And what is the next criteria? Next criteria is transfer time. Transfer time is the time to transfer the data. It depends on the rotating speed of the disk and number of bytes to be transformed. So that is transfer time. Then next point is wait. Then next point is disk access time. This is, or this time is, wait, let me write down a formula about disk access time. Disk access time can be, disk access time can be, or it can be written into seek time plus rotational latency plus transfer time. Plus transfer time. This is the definition of disk access time. Seek time plus rotational latency plus transfer time. And after disk access time, the next field is disk disk response time. Time. What is this response time? Response time is the average time spent by a request waiting to perform its I/O operation. Any questions? When I am silent, all of you are silent. No one is asking question. If there is no question, can I ask? Give me the definition of disk response time. I think all of you have understood, so you all are silent.
Ma'am, right now you said disk response time is the average access time. How fast the disk is responding. That is the disk response time.
Okay. Disk response time is the average of time spent by a request waiting to perform its IO operation. Average response time is the response time is measure of how a time is measure of how individual requests are searched with respect to average response time. So the click scheduling or so the disk scheduling that gives minimum variable response time is better. Whenever you write a big program, suppose actually in lab you always write very small program which get executed, but suppose you have written a big program and its calculation require a minimum number of time. Okay, that is disk response time, and always the disk scheduling algorithm that gives minimum variance response time is better. Okay. Now, what are the advantages of disk scheduling? Can anyone tell? Advantages of disk scheduling. Can anyone tell me?
Ma'am, we got faster
Yes,
computer.
whenever you are working with this, it is not that faster. Every request gets a fair chance. Each and every request is entertained. No indefinite postponement. Okay. So these are, what was the name of this algorithm? Did I tell you the name of this algorithm? No. I was just explaining the concept of disk scheduling algorithm. Look, in slot exam, I will cover this also. Disk scheduling will also be there in your slot exams. Up, I think up to this week. That means today.
Okay, ma'am.
Okay. Now, I want to go back to slide. You people, most of the people choose to remain silent. I don't know why. Disk scheduling, there are many sources of disk IO request, operating system, system process, number of process. So there are many sources. IO request includes input output mode, disk address, memory address, number of sectors to transfer. Number of sectors, number of track are present in disks. Operating system maintains queue of requests per disk or device. For per device, there is one queue. Idle disk can immediately work on input-output request, and busy disk work must queue. Optimization algorithm only makes sense when a queue exists. When there is only one process, then there is nothing to schedule. So optimization algorithm can make sense when queue exists. Why optimization algorithm? What is the meaning of the word optimization and what does optimization algorithm mean?
Optimization means the less wastage of resources.
Thank you. Optimization means not only not only wastage of resources in terms of output also. It gives fast that when you are searching for a particular sector or
Yes, ma'am, like proper utilization of resources.
yes, for resources, exactly. It can be in terms of time also. It can be in terms of performance also. Components of disk transfer, look, waiting for device, waiting for channel, then seek, rotational delay. Rotational delay means time which is spent um, in rotational delay, like seek, rotational delay and data transfer. Rotational delay means searching is occurring, which sector, which, where it is stored, and then at the end there is data transfer. When the data transfer or the device busy is consisting of seek, rotational and data transfer. These are the factors, the criteria based on which we can say that the device is busy and cannot be used. Disk scheduling algorithm. I will ask every one of you to go through disk scheduling algorithms. There are several algorithms, just like in FIFO, in just like in case of scheduling algorithm, there were FIFO, then preemptive, non-preemptive, round robin scheduling. There were several algorithms and techniques. In disk scheduling algorithm also, there are few techniques. So we will illustrate those techniques afterwards. First of all, here we will look that the device controller have small buffer and can manage a queue of input-output request of varying, depth. Several algorithms exist to schedule the servicing of disk I/O request. There are several algorithms, and the algorithm request is several algorithms exist to schedule the servicing of disk I/O request. That means it is very necessary to schedule the servicing of disk I/O request. The analysis is true for one or many platters. Platters, tracks, you can refer as tracks. We illustrate them with the help of input-output request queue. Cylinders are between 0 and 199. What is a cylinder? I have explained it by a diagram. Cylinder. But I don't know how many of you remember or not. If you have written anything or not, I don't know. But suppose this is an example. Suppose this is a queue. In this queue, these are the several elements, and the head starts at 53. Who is entering and leaving? FCFS, look, these are the algorithms on which the numerical will be based. Maybe in my next class will be, I think, on Monday. So next class, I will explain this scheduling algorithm. Okay. First come, first serve, shortest seek time first, elevator, circular scan, look, see loop. These are the names of some scheduling algorithms. FCFS handles IO requests sequentially and it remains fair to all processes. Approaches random scheduling in performance if there are many processes. That means random scheduling is done if there are several processes. Suffer from global zigzag effect. What is zigzag effect? Suffers from global zigzag effect. This is a homework for you all. I will, in my next class also, I will continue with this topic. Maybe we will solve some algorithm and look into some algorithm. But no answer. I'm not getting any answer. Global zigzag effect. I think all of you, this term is new for all of you. So all of you will find out what is global zigzag effect. F first come first serve. Suppose a queue is given, that it was earlier explained, or this example was taken. Head starts at 53. Look at the diagram that 53, from 53 it comes to 98. There is a pointer. Then from 98 it goes to 183. 183 it is linked to 37. Then from 37 it goes to 122. Also, then look, all these elements are covered and at the end there is 67. From 65 to 67. That from that edge is from 65 to 67. Is this diagram clear? When you look into the FCFS algorithm, the Q98, 183, 37, 122, 14, 124, 65, 67. Not getting answers. Please, all of you
Yes,
respond. Only one student responds.
Yes, ma'am, this is clear.
Only you are saying yes, madam. What about rest of the others? Who are else? Wait. Who are your rest? আরে ভাই, all of you are frightened. ভয় পাও কেন আমি বুঝতে পারি না। যেটা আছে মনে সেটা বলো। নেহা পাল, yesterday I আজকে খুব ভালো লাগলো তুমি আনমিউট করলে নিজেকে। নেহা, তুমি কি কিছু একটু দেখে বলতে পারবে? ছবিটা কি বোঝা গেছে?
ম্যাম আসলে আমার একটু
From 53 to 98. Why from 53 to 98? 53 is the head. So whenever we start traversing, we will start traversing with the help of 53. Then from 98, we reach to 98, first link. Then from 98, we move to 183. Others, only one student said no, the rest are not saying anything. Anyways, it is simple. Just look at the diagram, you will understand that it is just moving from one place to another, just like traversal. The addresses are given and it is just moving from a place to another place. Right.
Question shows a total head movement of 640 cylinders.
Yes.
The
इसका मतलब क्या हुआ? ये सिलेंडर्स कहाँ से आया? वो नहीं समझ में आया।
Cylinder, last class I have described the diagram. If you watch the last class video, you will find out cylinder. These
Okay,
are all structures for storage present in a disk. These are internal structures which you need to study.
okay, ma'am.
And in next class, I'm thinking of solving one problem or something of these algorithms. Since I will give in slot test, I will give the problems from here also and from scheduling algorithms also. They are more application based.
Okay, ma'am. Good.
Okay. So shortest seek time first selects the request with the minimum seek time from the current health position, also called shortest seek distance or shortest seek distance first, SSDF. It is savior or it is easier to compute disasters. It is biased in favor of the middle request. It's biased in favor of the middle cylinder's request. Again, I will request everyone to go through that slide where I have explained that tutorial where I have explained cylinder. In last class, I described it. SSTF scheduling is a form of SJF scheduling. May cause starvation of some request. Okay. It causes starvation of some request also because the largest process are not able to execute. That's all for today. The meeting will end now within 1 minute.